Hello everyone, so this is basically just a follow-up to the last general Eagle workflow video that I did. And this is just going to basically go a little bit more in depth about the tools that we are going to be using, and also some other things that may come up while working on projects. I'm going to open up Eagle here, and then this time we can actually go into our projects folder here, and then we can open up either the board or the schematic. And now that we have the schematic open, actually, or if we had the board open, the first thing we're going to want to do is actually open up the other one. So we're going to want to click on this button here, which opens up the board for the schematic. And so, as always, we're going to go in here, we're going to change our grid, or display our grid, I'm sorry, do not change the grid here. And then, so if we go to options, if we go to user interface, we get a few little interesting options. The coolest one is we can actually change the background in our schematic or our layout. So I enjoy having the black background for my my board there. I think it makes it look a lot more hacker and badass. And I tend to like the white background for the schematic, but if you feel so inclined, you can change it to black. But ultimately, a schematic is for readability, and so somebody can look at the schematic and understand what's going on in the circuit and what it's doing, right? So we want the schematic to be as easy to read as possible, and I don't really think that it's easier to read with the black background, but I also do think that the board is easier to read with a black background. So anyways, this is kind of bugging me. We also do have some other interesting options. So if we go to set, which is apparently short for settings. I have no freaking idea why they didn't just call it settings, but we also get some more options, so we can change the background to actually, a color if we feel so inclined. This is kind of interesting. We can change the way that the polygons fill. So instead of just filling in full black, we can choose like some sort of hatching pattern or dot pattern or some sort of alternative, which some people like because it's a little more eco-friendly. We can also do adjustments to our drill size options, which I do not recommend you ever fuck with. And then under miscellaneous, we do have this option, which I do like, which is display pad names, which by default is unchecked. So if we check that and press OK, and if we go into our board over here, we can see that it actually now tells us the name of all these pads, right? Which is useful when you're working on like Shield, because now I kind of know that's D12, that's D8, etc., right? So I think that's pretty darn cool. Alright, so I'm keeping both of these open actually for a reason. I mean, Eagle is actually kind of designed to be used with 2 monitors and a mouse for that point, so with the scroll wheel, because then you can actually zoom with the scroll wheel. So some of the tools are kind of built around that. So actually, if you use a show tool or a show object tool, let me zoom out a little bit here. What that does is it shows where in the board view a certain schematic component is. So if I click on this resistor, it will highlight this resistor in the board. If I click on this set of headers, it will highlight the headers. If I click on the shield, it will highlight the shield. So maybe nifty, but I generally work in one screen, so it doesn't really excite me. But anyway, so we also have the show edit objects or properties, which is actually pretty useful. So text can actually be kind of a bitch to deal with. If I wanted to edit this text right here, it's actually not very easy. The easiest way to do it is to use this tool. If I click on it, then I can go in, I can change it to 2017 or whatever, and it instantly updates. And it's actually way better than the alternatives. And then you can actually get access to additional information. So I can go in here, I can change the value of this to 15K, and then mirror it for some reason. So I can perform multiple actions, right? And that actually kind of makes it a little bit more readable. So there we go. Awesome. Cool. So we also have the option to see layers on the schematic view as well as the board view. So for instance, if I want to turn on the pins, then I now see all this information about the pins. But that kind of gets in the way and sucks. So I'm going to turn that back off. But for whatever reason, if you didn't want to show the values or the names of like the components, and if you just want to get like a clean sort of like circuitry but without the value sort of view, you could do that, right? So yeah, it is used. So it comes in handy every once in a while. Yeah, it's definitely more useful on the board view, but it exists on the schematic view as well. So we have our move tool, which we covered. We got the copy tool, which is more of a copy and paste tool, because if I click on it, then I can start pasting these, right? And then kind of go on. So it's a little bit different than the copy you're used to. There's also the mirror tool, which basically just flips the orientation of the object. So I think you kind of, oops, there we go. Get the gist there. But as you can see, it can kind of get messy on things that are already connected to other things. So generally you want to mirror something if it's not super complicated and has a bunch of connections, or if it's something that's unconnected to other things. In the same vein of the mirror, we also have the rotate tool, where we can rotate items by 90 degrees, which is the same action that we can perform while we're moving it and right-clicking as well. So two options for rotation there. So one of the most awkward and terrible aspects of Eagle is its grouping mechanism. So to illustrate this, I'm just going to kind of make a few copies of these resistors here. Alright, so let's say that I these resistors are connected to a circuit that has a sensor and like some sort of thing that's happening many times on your design, right? So say you have like 4 buttons. And the circuitry for those 4 buttons are exactly the same. So you don't want to like necessarily just like duplicate your actions 4 times and spend 4 times the amount of time. You want to do it once, connect it, or keep it unconnected, and then copy it, right? So so let's say that each of these resistors is one of those circuits, right? And I want to copy it. So in order to do operations on groups of items, you have to go through a very awkward sort of workflow. Where basically first you use the group tool by typing in group or clicking on the box, and then you click and drag over what you want your group to be. And once you have it selected, basically Eagle will default back to the tool that you used before you group them together, or the name of the tool that you type in now. So because I want to move it, I'm going to type in move, and then you can see it selected the move tool. And now that the move tool is active, that is the operation that I can perform on this group of objects, and that is the only operation I can perform on them. So if I right click, now I have to right click and then click on move group, and then I can move it. Now let me go over this again. So I want to move these. So I'm going to click on the move tool. I'm going to type in group. I'm going to group the objects. I'm going to right click, and that will allow me to move. Now you can see that my mouse is basically stuck relative to the group wherever I right clicked in order to reach that contextual menu, right? So that means that, let me select it again, if I right click over here and go to move group, everything is going to move according to my mouse relative to this tiny little fucking area in the corner of the screen. So if I want to move this group over here, that's literally impossible for me to do because I right clicked in the wrong area. So because of that, and the reason why I'm able to just do group and then move these objects immediately after is because move was a tool that I used before I selected group. So that's what Eagle defaults back to. So I'm going to want to right click basically on them, and it gives me all these other menu options. Now do not be fooled by this. these are not things you can perform on the group. If you do any of these, it will perform it only on the specific item that you right-clicked on. So if I want to say delete the entire group and select delete here, it will only delete the one component that I right-clicked on. Alright, so that sucks, but you learn a little bit. So I select group again, I'm going to right-click, and the best is towards the center but not on them. But let's say I did it on, then I still get access to this one and only operation that I can perform on the group. So if I click delete group, then I can delete the group. And the reason why I defaulted back to delete is because that was a tool that I used before group. So with default selected, and then if I use group, and now I want to actually perform move, I can type in move, press enter, then I can right click and have access to move. Alright, so that's one of the weirdest, most terrible things about Eagle, but yeah, just you'll learn to deal with it. Don't use change object properties. This is a really weird, complicated way to perform kind of bulk operations, but it's stupid. So insert paste is basically your way to transfer information from like multiple open files within Eagle. So it's not the paste you're used to. It's different. It's weird. You basically are never going to use it for the most part. I've never used it. Delete is delete. Add is add. Pin swap is allows you to basically change kind of the numbering and the circuitry for the pins. So if I click on like this pin right here, and then there, see how it switched the order of the pins. So so it can be useful for headers, so you don't have to like delete the connection and then reconnect it because you did it in the wrong order. You can use pin swap instead. Replace is actually very useful, and I'm surprised I didn't go over it earlier. But alright, so let's say that in our process of laying out this board, we decided that we don't really like this footprint for the resistors. We kind of want a little bit more space, and we just think it's kind of ugly. So the easiest way to do that is to use the replace tool. So you type in replace, and you can go in here, and I can go into, okay, so I'll type in resistor. It'll bring up all our different resistors, and let's say we're just like super crazy, and we decide this is the footprint we need. We're using giant 2-watt resistors now. So now we basically told Eagle what object we want to replace whatever object that we now are going to click on with. So now if I click on this resistor here, it's going to keep the same name, it's going to keep the same value, but it's going to replace the footprint. Alright, so it seems like it didn't really do anything, right? Like we didn't see any change. And that's because the way that the resistor we switched it out with, actually has the same display in the schematic view. But if we switch over to the board view here, we'll notice that it's replaced with these giant, ridiculous resistors. Oh, sorry. Yeah, so that's how we replace it. Now, obviously, this is something we would kind of hopefully want to do before we finish laying out the board. And if we do finish laying out the board, and if we decide to make a change that's this drastic, we should basically reroute everything, which I'll get to in a little bit. Alright, so where were we? So we also have gate swap, which you do not have to worry about. It has to do with swapping gates, similar to the pin swap, but dealing with gates. It doesn't really come up very much unless you use a lot of gates. So we have name, then value. We have smash, which is a very useful tool actually, especially for the aesthetically inclined. So for instance, see we have our Arduino Uno component here, and it has this name Arduino Uno Shield. and the type of component that it is down here, our Arduino R3 shield. Now, let's say that we want this text to actually be centered. If we click on the Move tool, there's no way for us to actually select this text and then move it around. And that's because the text is actually intrinsically linked to the component here. But we can actually sever that link and then basically smash this composite object that consists of like these lines and this text here and these pins and the text up here, and we can kind of smash into its individual components, and then we can move those around and sort of arrange it in a way that's more readable or more aesthetically pleasing. So I can type in smash here, and then if I click on the component, you can see that now I have those little crosshairs on the text. And it provides a line showing what component it's linked to. And then I'm able to actually independently move those around. I can make my adjustments. Bam, it looks way better. Fantastic. And then we have this. Which is something that I've never really used, so I assume it's something that you're not going to really need to use either. I also have split and bend align, which is basically you can kind of create these breakpoints and then modify your nets. And then we also have invoke, which is a way to sort of do cleaner sort of routing of gates. Once again, something that doesn't really come up. So we also see the sort of division line here, which the next sort of grouping of tools kind of fall in a different category. So we do have a tool called wire. Now, wire is not for connecting components. It's really for like drawing. So the idea of wire is use wire to create components, right? And if we go in here, and if we edit this, and we change its width to something like 2.6 or whatever, see? Basically, it's wires that are drawing these kind of footprints. They're not meant to connect components. So really kind of don't use wire unless you're using it to do like art on the board. Okay? Text will give you text. Same thing goes for circle. It's kind of meant for artistic purposes, right? So you can do, whatever weird thing. Okay, that's my logo there. So yeah, don't use circle. Arc is the same thing. Basically a circle. Rectangle is the same idea. It's also yeah, just use polygon instead of rectangle, basically. It's the same sort of idea, but it doesn't really have a use in schematic view unless you want to kind of like create art out of it, which you can. Yeah. We also have buses, so you can group together multiple nets into buses to connect things, but there's a cleaner, kind of better way to do this, which I will show you basically right now. Alright, cool, because next one is place net junction. So if you want to sort of add net junction to connect wires that are going over each other but are not connected to each other, if you want to connect them, you can manually place your net junctions to do that. The pop-up window will pop up asking you if that's what you want to do, and you can click yes. And then lastly, we have a label right here. So label is actually very nice. So let's add something to this. So let's say we want to add a second LED here. Oops. So actually, what I'm going to do is I'm going to use the copy tool. I'm going to copy the LED we had here, kind of move it right down. I'm going to go to net and connect this to digital pin 7. Why not? And give a little bit of a lead. I'm going to copy over my resistor. I'm going to add a little bit of a lead out of it. I'm going to copy my ground. And there we go. Alright, so now we have a second LED. But let's say that we have like 50 LEDs, and we don't want to have like all these connections right here. So we can actually delete these connections. We can use our net. We can give ourselves a little bit of a lead here. And we're going to basically move these LEDs over a little bit to give us some more space. So I'm going to type in move. I'm going to type in group. I'm going to select it, right click, click on move group. I'm going to move it to where I want it. I'm going to give myself a little bit of a lead here. A little bit of a lead here. Use the move tool to kind of tidy up. Bring this in a little bit. Oop. We'll make these a little bit standardized. Okay, wonderful. And then I can use the label tool down here to give myself a label for these nets. I'm right-clicking to rotate it, and it gives you by default these just sort of letterings, which I find very ugly and terrible, so I changed it to flags. And then 0.7 you'll run into trouble because they won't fit right next to each other, so I tend to bring this down to 0.5, which will give, bring it down to 0.4, which will give you enough space to have multiple lines of these. So I'm going to place my net on these pins here, my net label. I'm going to rotate this around. There we go. And yeah, it's still kind of tidy things up a little bit here. Alright, wonderful. So now we can use the name tool to actually change the name of these nets. So we can click on the name, and we will change the name of this to D7. It's going to zoom in a little bit here. And use the name tool again. We're going to change the name of this to D11. And notice I'm using this zoom select tool. I'm going to use that to select my work area, and then it's going to zoom me into that and center it. Zooming is kind of awkward. I definitely recommend a mouse if you can. Alright, so I'm going to use name again. I'm going to change the name of this net to D11. It's going to ask me if I want to connect them. So what it was previously named, as you can see, is N $8. And we want to change this name to D11. So we say, yes, we want to connect those. And by connecting it, we actually do change its name to the name of the bus, because that's what tells the program what is connected to what. It's basically the name of these different nets. So we're going to do the same up here. D7. Say yes, and they're connected. So this is actually really nice. It's kind of hard to see in something as small as this. But let's say that we're running out of space and we wanted to just we can put this anywhere now. So we can put this over here, for instance. We can use our text tool, and then we will call this headers. We'll change this to names, make it much larger. We have headers. And then we can do this as Arduino shield, right? So sometimes it's helpful to break things out in a way like this. Cool. Then down here we do have a few additional sort of hidden guys as well. So we have attribute, which you don't really have to worry about attribute. I'm pretty sure it has to do with circuit simulation, which is something that you don't really I'm not going to cover. Oops. And then we also have dimension, which allows us to give ourselves sort of dimensions, which doesn't really make sense in the schematic view, but it meant like maybe if you had like some crude drawing that you want to do to scale the project in the schematic view as well, I don't know. It's kind of weird. And then the same for module import. Just don't really worry about it. It's something that's not really going to come up, and it's something you're not really going to need. So that's a basic overview of the tools in the schematic view. In the board view, luckily things are almost exactly the same. We do have a few exceptions. Let's see here, make sure I'm not missing anything. We have optimize, which allows us to kind of fix mistakes that are made, mistakes that generally are going to arise if you use line or wire instead of route and net. So if you do accidentally use those and you find things are, like connected, but it's still throwing you errors and saying that it's not, you can use the join wire segment to basically electronically connect those components, even though physically, they actually already are connected. So the next tool that we have is the meander tool, and meander tool is a very interesting tool. So the idea of meander is that you enter in the name meander, and you also give it a length in inches. Let's say we're going to do 5 inches here, and you press enter, and then you click on a net segment, so a straight line. And then, so it says what our goal is here, 5 inches. And it also gives us 30.2%. And what that is that is a, that tells us that the length of the line segment right now is 30.2% of 5 inches. So the point of the meander tool is to make sure that traces are the same length. And this really only comes into like really, really insanely high frequency and high fidelity circuits in which you are worrying about the length of your traces. And for instance, like you have one trace that goes around a bend farther than the inside trace going around a bend. Therefore, it's longer than the other one. But you have to make sure that the electricity behaves in certain ways, and those traces have to be the same length. You can use the meander tool to basically make it longer and give you the length that you need. See, we're at 100% there, and it won't go any more than that. We could kind of bring it in and whatever. So basically, it's very interesting. It's something you're not going to use, but that's what it does. All right, excellent. Anyways, so these guys are all pretty much the same. One thing that is important to note is that you do use the route command to make connections instead of the net command on the board view. And then there is a lock command as well, so you can lock the position of parts, and then that way there's no way to basically oops, sorry. That way they just can't be moved. So for instance, if I select this group and then if I decide to move it, oops, everything moves except for those components that are locked. So this is actually kind of pretty handy. So you can lock some things in place, make sure they don't get moved. You can kind of go systematically through your board and kind of make optimizations and know what you have optimized and what you are what's left to be optimized, basically. Wonderful. So we do have a few hidden commands here as well. So we do have a via command. So vias are, as discussed earlier, they're basically connections from the top and bottom portions of the board. So for instance, we currently have a ground pour on the top of the board, and we also do have a ground pour on the bottom of the board. And those ground pours are technically connected through our through holes for our components. But let's say, for instance, instead of using through hole resistors, we're using surface mount resistors, which mounts on only one side of the board and doesn't have any connection to the second side of the board. We would kind of have two different ground planes. So one way to combat that is basically by placing some vias on the board in order to connect our two different ground planes. So we place the via, and then we do get some options on the via. So we get options as far as the general shape and also the size as well. So we have round, and square, and large, and small. So I place like 3 vias here, and I use the name tool. I can go into the via, I can change its names to ground, and that connects it to ground. And you can see, once I do that, it becomes actually connected to the ground plane and becomes one with the ground plane. Where before, oops. Okay, so if we hit rat's nest right now, you can see that the program is not connecting the via to the ground because it actually has a different name and therefore has a different net. All right, excellent. And then you can also place vias to go from one side of the board to the other side of the board as well. You actually press your middle mouse button while routing, and I'm using my laptop right now, so I can't really demonstrate it. But basically, you can start on one side of the board. You can start your trace, and then after a certain point, you right-click. After which, or I'm sorry, you middle mouse button click. It inserts a via for you with the correct name, and then it transfers you to the bottom layer of the board where you can continue routing. We also have signal, which I'm actually not really sure what that does. Hole allows us to place drill holes. So for instance, let's say that we were going to attach an accelerometer right here on top of the board. And the accelerometer has drill holes. We could basically figure out well, let's say we make these bigger, so we can set up 4 of these drill holes, and we can carefully measure the distance that they are on the accelerometer. We can put these drill holes into our shield. When we get the shield, they will be drilled out. And then we can put some spacers on top of the drill holes, and then we can attach the accelerometer directly onto the shield. So you can do nifty things like that. So drill holes are actually pretty handy. You don't really have to worry about attribute. That has to do with the way that logic ICs kind of interact with each other, and it's outside of the scope of this demonstration. Dimension was the same as before, but it's much more useful in the board view. And then we have our ERC, DRC, and then errors just basically goes through and it shows us any errors that we may have. So for instance, right now it's like, yo, this resistor is kind of on top of these other pins right here. That's an issue. Fantastic. Cool. So that concludes an overview of kind of the tools within Eagle. And yeah, I hope that's helpful, and as always, hit me up if you have any questions about this sort of stuff, and I'd be more than happy to try my best to help you out.